A very good morning, dear students. Today we are going to learn about the next important concept of our polymeric chemistry. Polymer chemistry includes natural rubber. And coming to the natural rubber is a naturally occurring polymer which is obtained from the latex of rubber trees. So we all know that rubber trees are mainly available in uh, Kerala in India. So in Kerala, the rubber trees they are growing. They are grown in only Kerala of India. So with this, we know that very importantly, the natural rubber is obtained from the latex of that is Hevia brasiliensis. It is obtained from the tree called Hevia brasiliensis, and the very important latex. It is a milky liquid which is present in either the latex vessel or in the cells of rubber producing plants. And here the liquid that is present in the so called rubber trees is with 30 to 40 percentage of rubber particles and 55 to 65 percentage of water and small amounts of protein, sterol, glycosides, resins, ash and sugars. So in order to extract the important rubber from this so called latex, we should make it a very important method that is called processing of natural rubber. So here in the processing of natural rubber, so the latex of uh, rubber tree is collected by making incision or by removing the bark on the top of the tree, or by making a very important incision on the top of the tree using a knife, and then we will place a very important container at the bottom of this incision so that the latex or the milk of rubber is in the form of emulsion, which is uh, going to get collect in the given beaker or any kind of container. So that the latex that is collected, which is now taken and it is treated with water, so that it is removing all the kind of impurities that are present in the latex, and this is called diluted latex. So the diluted latex, which is treated with some of the important coagulating agents, so we call them as the chemicals that are used in the formation of so-called coagulum or crude rubber. So the formed coagulum or crude rubber, which will be obtained by the addition of the coagulating agents or else like chemicals like acetic acid, formic acid are added in order to make the coagulum or crude rubber that is obtained from the so-called diluted latex. The formed crude rubber or coagulum, it is rolled into sheets. So then the obtained sheets of crude rubber, they are sent to the very important next stage, that is make it into a size of a crepe paper with 1 mm diameter, so that the crepe rubber is obtained after treating the coagulum or crude rubber sheets for a temperature of about at a temperature that is 40 to 50 degrees centigrade, so that the formation of a crepe sized paper containing rubber sheets, and that type of rubber is called crepe rubber. So after forming this crepe rubber, we can also get a new type of and another type of rubber from the crepe rubber. So that is this coagulum or crude rubber, which is now heated to a temperature of 40 to 50 degrees centigrade again inside the smoked rooms. It is kept inside the smoked rooms for about 3 to 4 days. So the type of rubber that is obtained is called smoked rubber. So here the very important processing of the rubber includes all these stages. So during this process we are going to add some of the important so-called chemicals which will absorb the moisture, like sodium bisulfite, which can remove any kind of moisture present in the rubber material. And here there are some articles for use in medical and health sector which are prepared from the rubber. The consumer products like golf or football and other recreational sports goods, erasers, footwear and other apparels, all these are obtained from the so-called the rubber tree, that is Hevea brasiliensis. And here the X-ray diffraction studies reveal the natural rubber is in cis arrangement or cis form, and here the rubber actually it is a polymer of isoprene units. Here a monomer of this rubber is monomer of this rubber is isoprene, which is represented as 2-methyl 1,3 butadiene. And we have learned this in our last class also, the very important so-called 1,3 butadiene, 2-methyl 1,3 butadiene is called isoprene. This 2-methyl 1,3 butadiene, which is undergoing the process of copolymerization, and it is converted into, or it is giving rise to the formation of polyisoprene, and which is called natural rubber. And this natural rubber, which is showing very important cis arrangement, while we study regarding the X-ray diffraction studies, X-ray diffraction studies of natural rubber gives cis arrangement of the so-called natural rubber. Okay, so here next we will be moving on to a very important concept, that is called processing of natural rubber and then vulcanization. So here the processing of natural rubber, the production of rubber is followed by processing into final products consists of compounding, mixing, shaping, vulcanizing. And here the processing techniques for natural and synthetic rubbers are, they are virtually the same, differences being the chemicals used to affect vulcanization. And we are all mainly concentrating on the applications of natural rubber. So there are mainly so many applications are there for natural rubber, we know very well, we have learned just now. So the main applications we have seen already. So let us move on to the processing with a vulcanization process. So vulcanization is the complete process of addition of sulfur to the natural rubber, and the polyisoprene long chains, they are linked by sulfide bonds, and these sulfide bonds will increases the stability of the molecule. That means, what is vulcanization means? The process of addition of sulfur to polyisoprene, that is natural rubber, in order to increase the characteristic properties of the natural rubber at a temperature of 100 to 140 degrees centigrade. And the common sulfur adding chemicals, or we can call them as the very important so-called chemicals that are providing sulfide bonds, are hydrogen sulfide, thionyl chloride, and even sulfur monochloride, and so on. Even we can have hydrogen peroxide and all. So these are the chemicals which are called the very important vulcanizing agents. So these vulcanizing agents that are importantly involved in the process of vulcanization, and the vulcanization creates very important cross connections between the polymers of the rubbers. And here the increasing cross connections decreases the elasticity, and without vulcanization rubber would remain sticky. You see, vulcanization is the one of the very important process there are various important characteristics of the rubber are improved. And here you see the vulcanization, where the chemical reaction included in this vulcanization is the polyisoprene long chain, which is added with a very important sulfur, that is H2S, at a temperature of 100 to 140 degrees Celsius, and the two long chain polyisoprenes which are linked by sulfide bonds at its so called olefinic bond region or double bond region. The bonds are new bonds are formed, or new sulfide bonds are formed at its olefinic bond positions. Okay, so this is the process of vulcanization, and here the vulcanization makes the very important gives the required elasticity, gives the required tensile strength, stability and toughness. Even it also provides different types of improved characteristic properties like tackiness, resilience, and so many important factors or so many important properties. So that is why vulcanization is one of the very important method of processing of rubber. Okay, so after that we will be moving on to what are the main so called improved characteristic properties of rubber after vulcanization. You see, after vulcanization, so the natural rubber having the percentage of elongation is around 800, whereas it has been improved to 1200. And after that, the tensile strength of the natural rubber is 200 kilograms per centimeter square, but it is improved to much to an extent of 2000 kilograms per centimeter square in the case of vulcanized rubber. And you see the very important tackiness. So in the case of natural rubber, it has a very good tackiness, that is marked tackiness, but in the case of vulcanized rubber, it has slight tackiness. And what is the meaning of tackiness? Means when two rubbers coalesce to form one single rubber, it is called tackiness. And the next one, that is called the temperature resistance. So temperature resistance of the natural rubber is somewhat good. So but in the case of vulcanized rubber, its temperature stability is very good or very high. And coming to the next one, the resilience property. The natural rubber has low resilience property, whereas vulcanized rubber has got high resilience property. What is the resilience means? Property means the property of bringing back rubber when it is stretched against when it is stretched against any force. When we stretch rubber, it will show the very important deformation, and when we release that rubber, and it will undergo reformation, and this property of bringing back to its original form is called as resilience. Okay, and next is the very important the property that is called here because of the vulcanization process, there are many important properties, like all these are improved, along with this very important swelling in organic solvents. So in the case of natural rubber, it will swells in organic solvents to a very good extent, whereas vulcanization rubber does not show the swelling in solvents. That means here the absorption of solvents will be observed in the case of absorption of solvents is more in the case of natural rubber, whereas it is very less in the case of vulcanized rubber. Okay, this is all related to the vulcanization of rubber. And now we are moving on to the very important synthetic rubber. So what is a synthetic rubber? Means synthetic rubbers are complex chemical compounds formed through the polymerization of monomers, and the typical monomers used for production feed materials include butadiene, styrene, isoprene, chloroprene, acrylonitrile, ethylene, or propylene. Here the synthetic rubber production starts with a refining process of oil, coal or other hydrocarbons with naphtha as one of the desired products. And let us have the very important the first important category of the rubber, that is called styrene rubber or styrene butadiene rubber, which is also called cold SBR. So this styrene butadiene rubber, it is derived from the copolymerization of styrene and 1,3 butadiene. So here the styrene content in the range of 10 to 25% and butadiene unit is composed approximately 60 to 70%. And here the styrene, which is represented as CH2 double bond CH C6H5, and butadiene is represented as CH2 double bond CH CH double bond CH2. And on copolymerization reaction, it gives rise to the formation of a very important long chain substance, that is a polymer, which is called styrene butadiene rubber. So which is represented as CH2 single bond CH double bond CH CH double bond CH2 single bond CH double bond CH double bond CH2. Here I will tell you once again, the product of styrene butadiene rubber is obtained from CH2 single bond CH double bond CH2 single bond CH2 single bond CH C6H5 taken n times. This is the very important styrene butadiene rubber. And there are very important properties and uses of this styrene butadiene rubber. Styrene butadiene rubber is very easily undergoing the process of oxidation in the presence of ozone atmosphere, and it shows a very good resistance to abrasion, and it has a very high load bearing capacity, and it shows very important resistance to almost all acids and alkalis and even solvents also. So these are the very important points related to styrene butadiene rubber. And coming to the uses of styrene butadiene rubber, the major use of styrene butadiene rubber is in the production of tires, particularly car and lightweight vehicle tires. Cold emulsions SBR is especially used in light duty tires. SBR, that is styrene butadiene rubber, can also be found in industrial applications as insulation for wire and cablings and roll coverings, hoses, gaskets, seals. And it also included with shoe soles, carpets, adhesives, and in molding rubber goods. These are the important uses of styrene butadiene rubber. Okay, next we are having the second important type of rubber, that is called nitrile rubber or nitrile rubber or acrylonitrile rubber. Let us have the very important nitrile rubber or nitrile butadiene rubber. So nitrile rubber is a copolymer which is obtained by the chemical reaction between or copolymerization of butadiene, which is taken in 75 parts, and acrylonitrile, which is taken in 25 parts. That is 75% of butadiene which undergoes copolymerization reaction with 25% of acrylonitrile. And here these are the very important reactants which undergo copolymerization. And the nitrile rubber is also known as buna-N, so which is called perbunan and acrylonitrile butadiene rubber. And here these are emulsified in water and then polymerized through the action of free radical initiators. And the chemical reaction includes CH2 CH CH2 CH double bond CH2 taken N, CH2 CHCN CH2 taken M times. This is the Buna N, and it is prepared from the butadiene, that is CH2 double bond CH double bond CH2, which is called 1,3 butadiene, which reacts with acrylonitrile, that is CH2 double bond CHCN, and gives rise to the formation of CH2 CH double bond CH2 CHCN taken N times, or else we can represent it in this way. Okay, now we have some of the important applications of nitrile rubber, and before going to applications, there are some important properties of nitrile rubber. That is, it is one of the very important type of rubber which shows a very good resistance to heat. It shows very good resistance to oils, and even it also shows very good resistance to the ozone. So therefore here it is having very good resistance to all type of acids and salts and solvents. But you see, it can be easily attacked by the alkalis because due to the presence of cyano groups. Okay, and let us have the next important point, that is application of Buna N. So this Buna N is popular and in its applications, and requiring oil resistance, performance under extreme temperatures, and personal protection. Actually, it is used in automotive industry, useful for gaskets and engine hoses. Even it is also used to make in rolls in the printing industry, like printing rollers, and even that can spread inks. They're also used in textiles to waterproof fabric and improve the finish. And nitrile gloves can range from heavy duty gloves, footwear, floor mats, sponges, and a host of molded goods. So these are the important applications of Buna N rubber. After this, we are moving on to the next important type of polymers. We call them as conducting polymers. So what are conducting polymers means? Conducting polymers are the polymers which are having conductivity. So first, in the beginning of 19th or 20th century, the scientists started to believe that polymers are insulators, and they are the poor conductors of electricity, and therefore we consider them as insulators. Absolutely. But after the advent of the advancements in the technology, and the scientists started to synthesize some of the important polymers with good conductivity, and these polymers with much improved conductivity is mainly due to the presence of a backbone with conjugated pi electron system, and hence the delocalized pi electrons will results in conductivity of the given polymer, and therefore the conducting polymers are defined as the polymers with conjugated pi electron system which possess electrical properties in par with mechanical properties. These are called conducting polymers, and there are some examples of these conducting polymers like polyacetylene, polyaniline, polythiophene, polyphenylene vinylene, and polyperols. So we have next one. So the condition to become conductive. So here there are two main conditions for a polymer to become conducting. The first condition is that the polymer consists of alternating single and double bonds, and this property is called conjugated system or conjugated double bonds. So here in this given picture, the polyacetylene is having conjugative system of double bond followed by single bond, that is alternating fashion of double and single bonds. And the second condition is the process of doping. You see, the doping is one of the very important property, a characteristic addition of some impurities or chemicals which improves the conducting property. And here you can see there the polyacetylene is doped with so-called iodine and even with sodium, and that results in a doped conducting polymer. Okay, so here we have there are various important types, or in the classification of polymers there are various important types of polymers. Let us have the types of conducting polymers or classification of conducting polymers. In the classification of conducting polymers, the first important classification is that here there are the very important intrinsically conducting polymers or pi electron conjugative conducting polymers. So the intrinsical conducting polymers or pi electron conjugative conducting polymers are the polymers in which the main chain consisting of conjugated pi electron and the backbone is with conjugated pi electron system, and hence this type of polymer is called conjugated pi electron conducting polymer or intrinsically conducting polymer. And these intrinsically conducting polymers are having low conductivity, and the conductivity can be improved to a good extent by means of some very important chemical reactions. So let us go for the second important category of the conducting polymers classification. Includes this so-called extrinsically conducting polymers. And before that we have doped conducting polymers. So what are doped conducting polymers means? Doped conducting polymers are the polymers here there is an addition of a charge transfer agent, so that the very important formation of a charge on the surface of the polymer chain backbone, either it is a positive charge or else it is a negative charge that is generated on the surface of the polymer chain, and that causes a very important conductivity of the given polymer, and its conductivity is much improved. And that can be explained with positive doping, that is p doping, where the positive charge gets delocalized on the top of the conducting polymer, and therefore the type of polymer that is obtained is called p doped conducting polymer. In the case of p doping, so the conducting polymer which is going to react with Lewis acid in the presence of p dopants like I2, Br2, ASF5, and we observe there is a very important type of p doping, and here the very important p doping is taking place by a process called oxidation by the loss of electrons, and therefore it generates a positive charge on the top of the polymer chain backbone, and it is called p doping, and the final polymer that is obtained is called p doped conducting polymer. And next we have the n doping. In the case of n doping, so the conducting polymer which is like polyacetylene, it is going to react with here you see the very important p doping. Let us take p doping with an example I would like to show. So here there is a CH taken N, so which is a polyacetylene, so which is reacting with I2 and gives rise to the formation of the CH taken N with a positive charge I3 minus. That means here the long chain backbone of polyacetylene consisting of positive charge, and hence it is called p doping. Whereas the next one that is called n doping, where the conducting polymer which reacts with Lewis base in the presence of n doped dopants like we have lithium, sodium, calcium, etc., and these will result in formation of a very important product that is called n doped conducting polymer, and it is explained as with a very important examples. Now the long chain backbone is going to be having negative charge, so that the negative charge is delocalized and it is called n doping. So next after this we have extrinsically conducting polymer. The extrinsically conducting polymers are the polymers where there are some chemicals that are added externally, and so that the conductivity of the polymer is much improved. And here the extrinsically conducting polymers are again of two types. So one is called the very important type of so-called uh, blended conducting polymer. Blended conducting polymer is a type of polymer in which a conventional polymer is blended or mixed with a conducting polymer, and the resulting polymer that is obtained is called blended conducting polymer. So this is the blended conducting polymer. And after this, next we have the next important category of the polymers, that is called uh, inorganic or coordination conducting polymers. So here inorganic or coordination conducting polymers are a type of polymers in which, so they are like metal ligand complexes in which an electron donating ligand will will react with electron accepting metal, that is a polydentate ligand which is reacting with a metal, so where it gives rise to the formation of a metal ligand complex, and the formed metal ligand complex which gives a coordination complex as like a very much improved with conductivity, and this type of polymer is called inorganic or coordination conducting polymer. Like this we have the very important intrinsically conducting polymers or else conjugated pi electron conducting polymers. Next, doped conducting polymers with p doping and n doping. Next, third one, extrinsically conducting polymers, and fourth one, that is called blended conducting polymer, and the fifth one, that is called inorganic or coordination conducting polymers. So these are the very important types of polymers of conducting type. After this we will be moving on to the synthesis of different types of polymers. Here, in order to synthesize, let us take one normal example. It is very important that to synthesize polyaniline, let us take the synthesis of polyaniline. So the polyaniline can be synthesized from, so a very important chemical reaction that is included here. So C6H5NH2HCl, which is called aniline, hydrochloric acid, which reacts with NH4 taken twice, S2O8, gives rise to the formation of polyaniline along with 2NHCl, 5NH2SO4 and 5NH4 twice SO4. Here the oxidation of aniline hydrochloride with ammonium peroxy disulfate yields polyaniline, and it is an emeraldine hydrochloride. Okay, and here you see the synthesis of polyacetylene is represented from acetylene, that is with the Ziegler-Natta catalyst. First acetylene which reacts with Ziegler-Natta catalyst and gives rise to the formation of the polyacetylene, which is represented as CH triple bond CH gives rise to, and the catalyst is Ziegler-Natta catalyst, that is titanium complex, that is we have TiOPr taken 4 slash ALET taken thrice, that is triethyl aluminium, and the very important complex of titanium, and gives rise to this very important polyacetylene. This is one of the very important method, and you see the factors that are affecting the conductivity. There are some 5 important factors which affect the conductivity, starting with density of charge carriers, the mobility, direction, presence of doping materials, like they facilitate the polymer conductivity, so in the form of additives. And the fifth one is temperature. And we can say that the conducting polymers have got many number of applications in different fields. Let us have some of the main important applications. So they are mainly used as an anti-static coating for cloths, as well as anti-static coating for photographic films, and used as corrosion inhibitors. They are used in telecommunication devices, and they are also used in non-linear optical materials. They are also used in the case of the electromagnetic materials, and they are also used in compact capacitors, and they are also used in the transistors. They are also used in sensors, and even they are also used in light emitting diodes, and in some of the important very useful solar cells. Nowadays we are mainly depending on renewable energy sources, therefore these conducting polymers are also used in solar cells like photovoltaic cells. And next, they are also used in display screens of mobile and many format television screens. So these are all the important applications of conducting polymers. Okay, hope you all understood. Okay, let us have a small important topic to be learned, that is called as what is the silicone rubber. So this is there. So let us have these 2 points. Silicone rubber or silicone rubber is most commonly used synthetic rubber or polymer, and here there is a similar bond structure as found in glass, sand and quartz, and it is composed of silicone, which itself is a polymer, together with hydrogen, carbon and oxygen, and it is made from cross-linked polymer that is reinforced with silica. And the main important applications of silicone rubber is electronic insulating tape, varnish, lubricants, keyboards and housings. They're also used in aerospace, space suit fabrics, tooling materials, gaskets and seals. And they're also used in construction uses like for the adhesives, coatings and sealants. And in the case of consumer materials like anti-stick bakeware, food containers, utensils, toys and jewelry. And in some medical, silicone rubber uses are found in the tubings, adhesives and deformers. Okay, so like this we have come to the end of our polymer chemistry. So thank you.